A parallelogram is a quadrilateral with two pairs of parallel sides. That's the definition of a parallelogram. Parallelograms also have many useful properties. One property is that if we have a parallelogram, opposite sides are congruent. The converse is, if opposite sides of a quadrilateral are congruent, then it's a parallelogram. Can we prove the converse is true? We start with a quadrilateral with congruent sides. Let's add a diagonal. BD is in both triangles, and BD is congruent to BD by the reflexive property. Can you prove the triangles are congruent? There are three pairs of sides congruent: here, here, and here. Triangle ABD is congruent to triangle CDB by side, side, side. But that doesn't make the lines parallel. We'll need to label some angles. And if we can prove some angles are congruent, we'll be able to prove parallel lines. 1 and 2 are alternate interior angles. 3 and 4 are also alternate interior angles. Angle 1 is congruent to angle 2 because corresponding parts of congruent triangles are congruent. The same is true for 3 and 4. AB is parallel to CD, and BC is parallel to DA by the converse of the alternate interior angle theorem. Since opposite sides are parallel, ABCD is a parallelogram. Because we proved the converse of a property, we now have a tool to prove a quadrilateral is a parallelogram. If you see a quadrilateral with opposite sides congruent, you can use this converse to prove it's a parallelogram in one step.